we're going to go on now to week 2, extrema and rates of change. For this week, we will continue to work with graphs of derivatives and the concept of derivatives, plus adding in some more applications of derivatives. So go ahead, next slide, please. Got 2 objectives. I think that will be our regular on our regular agenda, 2 different objectives. Our first one will be calculating rates of change. So again, before we get started with this, I would like everybody to just grab a piece of paper and a pencil. So we are doing 2 different objectives, calculating rates of change and interpreting graphs. So let's get started with calculating rates of change. So we're going to be estimating and calculating instantaneous rates of change of functions in the context of AP problems, also applying rates of change to locate absolute and local or relative extrema. You should know that the first week's presentation is accessible within the Sprint 2 program workshop materials. So even though you missed the first week, you can watch the recording or at least look at the slides and be able to catch up. Just make sure you know that material, since that will also help you with what we're doing now and the rest of the time. So we just want to know what you remember from class about which of these expressions relate to finding the derivative of the actual function, and which of these expressions relate to using the slope formula. All right. So for group A, hopefully you find the instantaneous velocity, find the slope of the tangent line, find the derivative of the tangent, and find the instantaneous rate of change of the function. So when you're finding instantaneous rate of change, instantaneous velocity, this always means to use the derivative. But wherever you're going to see in AP problems estimate the instantaneous rate of change or velocity, or anything that's related to slope of the secant or average rate of change, average velocity, these are the words estimate. Even if it says instantaneous rate of change, if it says estimate, you need to use the slope of the secant. How'd you guys do? And so now Kylie's going to put in the chat a link to some more questions. I made up like an AP FRQ that will help you to practice. So let's see if you're able to know from this practice which of the wordings relate to slope of the secant and which of the wordings relate to using the derivative.